When it comes to programming, I'm in this weird spot where I can finish the homework from the intro class in a few minutes, but my two brain cells die when I try to solve a simple competition problem. A few weeks ago, I made the game Tetris in JavaScript after my teacher challenged me to do it. But recently, I was bored after I finished the 4 problems on a unit test in half the test time, so I decided to try to make my other favorite classic game, Minesweeper.
Sunset, never gonna be the same. Thunder calling us to outer space, escaping gravity.
Alright, before I start the process of making the game, I'm going to explain how it works. Basically, you have a board of whatever size you want with a certain number of mines on it. The goal is to open every single cell that doesn't have a mine. Usually the first few clicks of any Minesweeper game are just guesses, but let's look at this cell right here. Look at the one that's only touching this one cell. Because that one is only touching that one cell and it has to have one mine, that means this cell has to be a mine. So we can go ahead and flag this cell. Now look at this one that's at the cursor. Because it only needs one mine and there's already one mine that it's touching, that means all other cells, in this case only this other one, it's touching must be safe, so we can go ahead and open that cell. These are examples of the two basic logic patterns of Minesweeper. If a number is touching the same number of cells as the number itself, then all of those cells must be mines. And if a number is touching the same number of mines as the number itself, then all remaining cells it's touching are safe. We can use a combination of these two logic patterns as well as some more complicated ones to solve the entire board. When I said I made this during a test, that was kinda a lie, because I really only had time to define the variables and make a half-working board generation function, so there was a lot of work to be done. I'm at the random board generation and I've already run into a problem. So right here I'm trying to see if a tile is empty and hasn't been set as a mine yet, and it's giving me this error and I have no idea how to fix that. So this might take a while. I just spent like 30 minutes figuring it out, and it turns out I swapped the position of the Y and the X here, and I forgot to include the fact that in JavaScript the arrays and stuff start with 0 and go up from there instead of starting with 1. I then added the function to draw the tiles and numbers onto the screen. It didn't take me a long time to make one though, because I already had some pre-made code from Tetris. I don't have much time today, so I'm ending day 1 with a working graphics system. The main thing I added today was the ability to open cells. The top part of the function first checks if the cell that they want to open is a mine, and if it is, it immediately ends the game. Otherwise, it finds the number that needs to go there and displays that as the cell. That's not all there is to this function though. If I just left the function as that, then whenever I open a cell that has 0 mines next to it, I'd have to open all of the adjacent ones, even though I already know they're already safe. But I want the game to do that for me. And a lot of Minesweeper games already have this function built in called zero spreading. Essentially, when a cell is 0, it just automatically opens all nearby cells, allowing you to open big pockets like this. The way I did this was the bottom part of the function, where it sees if the number of mines touching it is 0, and if it is, it opens all adjacent cells by calling itself on all the adjacent ones. I was trying to add flagging to this game, but whenever I did that, it gave me this error, and I don't have time to deal with that today. So I'm just going to fix it tomorrow. So it turns out that my flagging function wasn't working for the stupidest reason, which was that I used separated if statements rather than if-else statements, which meant it was immediately flagging the cell and then immediately unflagging it right after. Fortunately, that is an easy fix. I can just change it to else-if statements. Also, since the website I used to code this doesn't know the difference between left click and right click, and it doesn't even allow you to right click, I just found the flag function to the F key. I also added the end screen today. In Minesweeper, a game ends if either a player opens a cell with a mine, after which it reveals every single other cell that has a mine that hasn't been opened, and it marks all potential false flags as false flags. Or when a player opens every cell that's not a mine, in which case every single unflagged mine gets flagged. This function starts by checking if the lose condition is met or if a mine is open. An open mine is denoted with the number 9 in this game. If it's not, then it checks to see if it satisfies the win condition, which is it's either a number or it's a 0 or it's a flagged or unopened mine. If it does, then it adds one to the cleared tiles variable. If the lose condition is met, the game changes every instance of the number 11 on the board to a 10, which exposes all of the unopened, unflagged mines, and it changes any falsely flagged mines 22 to a 32, which exposes them as well. Otherwise, it checks if the win condition is met, that is, if every single tile is cleared. In that case, it flags every single unflagged mine. The entire game works now, but is kind of hard to play, because if I know that a cell has a certain number of safe cells, then I need to go and click all of them myself to open them. Most Minesweeper games have a function called courting, where if you click a number that already has that number of flags attached to it, it automatically opens all nearby cells, and I decided to add that today. This was part of the function I used to see how many touching flagging cells there were. Notice it also has one for checking touching closed cells, which I'm going to get to later. This part of the code opens every single unflagged cell if the other criteria for courting is met. Now remember that earlier statement I mentioned like 10 seconds ago that checks for the number of closed cells? Well, what's that for? This is actually a completely new Minesweeper mechanic that I created called reverse courting. Remember those two basic logic patterns from earlier? Well, courting is basically just a quick way to apply the second one, but if I want to apply the first one, I'll have to do that myself. That is, until now that I made a shortcut for it. I made this part of the function that checks if the number of closed cells a number is touching is equal to the number itself, in which case it flags every single one of those cells. That way, if I wanted to rapidly flag cells, I can just click the number. Unlike Tetris, there aren't really any major game-breaking bugs in my Minesweeper game, so I can move straight onto UI and just finish the project. That didn't mean it didn't have its fair share of problems due to me being an idiot programmer though. So apparently this computer doesn't know how to do math, because right now I have this thing where I'm trying to get it to display the number of unflagged mines, and I just have this thing set up right here, and it knows that mines is 99 and flags is 0. But when I run this, yeah. Okay, so it turns out I redefined mines right here. How did I not catch that? The UI I made for this game is quite basic. It's just some text that displays the number of unflagged mines and time, but I think it works. And as always, I'm Alex Lee, this was my Minesweeper game in JavaScript, and thanks for watching.